Welcome back to Air Quality Matters. We already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and coming up, a conversation with Bill Bahnfleth. He is an ASHRAE Fellow and a former president of the organisation, a professor at the Department of Architectural Engineering at Penn State University, and much more besides. I think the perfect way of summing Bill up is in his own words. I would describe my interest and goals as falling into the gap between practice, which frequently lacks rigour, and science, which frequently ignores practical concerns. I try to identify problems that are of significance to practitioners in my areas of expertise and do research that addresses them in useful ways. I think that's perfect. There are few people on the circuit I enjoy talking to more. I have a huge amount of respect for Bill, as does a lot of the industry. His insights are real and grounded in years of experience, as he puts it, bridging the gap between the academic and the practical. And it is largely on that basis we talked. This space feels like it's in transition at the moment, and this is a rubber meets the road conversation. Standards, 241, quality, perspective, skills, and much more. I hope you enjoyed the chat as much as I did. Don't forget to check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Bill Bahnfleth. As a past president looking into this next phase of presidency of ASHRAE, seeing where we are at a global level with ventilation and air quality, like you're privileged to do with your travels and things, just a kind of a state of the art conversation about where we kind of think we are right now. Because it seems to me it's an odd place. You know, we're in a weird kind of post-pandemic, technology's moved on a lot. Sustainability is in a bit of a weird place as well. It seems a bit at sea to me somehow, ventilation and air quality, and it almost feels like we need some kind of a reset somehow and a direction. And it's not for a lack of regulations and standards. We've had this conversation loads. I think there's plenty of good standards out there. I think there's a lot of good benchmarks, you know, kind of performance specifications like WELL and Reset and BREEAM and LEED and plenty of others. There's a lot of activity in, you know, I'm attending the thing in the UN at the end of September. Like there's all sorts of people trying for global standards and global statements on the importance of air quality. And I just thought it'd be really interesting to chat to you about where, from your perspective, where you kind of think we are, you know, as a society in this journey.
You said there's no lack of standards and rating systems and that sort of thing, and I agree with that. I think a point that came out at the Healthy Buildings India conference in our panel discussion was the issue of enforcement. That I think that we have a pretty good understanding of what we ought to be doing, but in general we're not doing it. And you know, you mentioned, you know, the idea of needing a reset. I thought COVID was the reset. I thought, oh, here we are after all of this time. Now we've got everyone paying attention to the issues of indoor air quality and how quickly that all fades away, and we get absorbed by other concerns. And certainly the general public, you know, ventilation is not something that is really top of mind for a homeowner. So when I travel all over the world, I see some local differences. You know, there are places where outdoor air is the only indoor air quality control that gets any credibility. I think Europe has been a ventilation-focused market for a long time. You go other places, and it is very energy intensive to use outdoor air, and so that doesn't seem to be considered to be a great option. But then when you go into just typical buildings, not the high profile buildings, the signature buildings, what you see is lots of buildings that are really designed to bare minimum and not maintained very well. And I think that's the thing that stands out to me is just the problem of maintenance worldwide. That's probably the most consistent uh, characteristic of HVAC systems is that once they're designed and constructed, that we don't take care of them the way we ought to, and then we pay a price for that. So that's why in my own statements lately, I've been focusing on simply getting us to baseline in a more consistent way. The, we have kind of a stratification, isn't it? It's the era of polar opposites, and in politics we have really extreme positions, and I think there's this kind of an academic thought leader kind of view of what's possible in buildings and what we should be doing to control indoor environmental quality. And then there's what's actually done, how the construction industry works and how the building management industry works. And I think those who are trying to change the paradigm maybe are out in front a little bit too far. There's a saying, I think it was attributed to Dwight Eisenhower, but it doesn't really matter, that if you're leading every once in a while, you should look around to see if anyone is following you. I think that's what I get from going to academic conferences and then seeing what's actually happening. And I that's a perspective that I have because I've been in both worlds. And I do think that sometimes the practice just doesn't really pay much attention to what's going on at the fringes of research.
Yeah, that is a really good point. And there's about 4 or 5 things to unpack just in that opening dialogue there. I think several things jump out to me. One of them is this global perspective, and the more you travel and the more people you speak to, the more you realize the regional differences, and a one size will not fit all globally when it comes to ventilation practice and air quality standards. And every country and every jurisdiction and every region is fighting its own battles from all sorts of different angles. So whatever the approach is to improve buildings, it's got to be fit for purpose for the region or area or people that it represents, doesn't it?
Yeah, it needs to give due consideration to what's possible in terms of economics, what is the state of things culturally, how our buildings regulated, all of those things. So I never assume when I travel around as an ASHRAE Distinguished Lecturer that my case studies of how wonderful some system type is in the U.S., even if I was directly involved in designing it, that's going to translate. So immediately after you give your story, people come up and start saying, well, this is different here and that's different here, and you have to go back to ground zero and see whether you can actually make that solution work in that environment. That's a good test. I think it breaks you free of the notion that any problem has been completely solved once and for all with a single solution. And that just doesn't happen. Of course, that's the truth of regulations as well. It's not just technology. We have several groups now that are trying, it seems, to establish global standards for indoor environmental quality. And when you start to get into the details of that, I think you have to conclude that while we have some high-level concepts that are global, in the end, all regulation is local, and you have to come up with a regulatory framework that works more or less country by country.
Increasingly, I'm looking at the social science angle of this as well, that, if the goal is standards, that's one thing, or if the goal is to show the art of the possible, that's another. And both are equally valuable in moving society forward. But sometimes if you're interested in moving the needle for people's health and well-being outcomes, sometimes that doesn't even sit with engineering and the built environment. It sits with income and economics and culture and habit. And these are much more nuanced affairs to try and dial in on and affect change, particularly the income one. And, sustainability has had this battle for a long time, that, we can argue that you can decarbonize grids and, decarbonize the built environment. But actually, in some regions of the world, the best thing you can do to lift people out of fuel poverty is improve economics, and what's that saying? It's economics stupid. It's always economics. That at some level, for people to have the agency to make a difference to their own health and well-being, they need the income and the freedom to do that. And when we talk, and that applies in every country. Not just in perhaps areas of the global south or developing countries. That can happen within our own countries, in the US and UK and Ireland. There are quarters of our society that simply just do not have the agency to improve their outcomes on their own.
Yeah, I think that's true. I think we can all agree in at some level with the WHO statement that air and water of acceptable quality are fundamental human rights. We want everybody to have it, but then you run into these economic differences that have a very great impact on how you're going to do that. Take, for example, in the literature I've been reading recently, and in a lot of discussions I've had, there are a lot of folks who are just completely sold on the idea that we aren't going to have good indoor air quality until we deploy lots of sensors and have smart systems to interpret them in real time. And there are a lot of places where that's just a total non-starter. So what do we do for those parts of the world? And if we can get by with fewer sensors there, then do we really need all the sensors we're talking about using in buildings now? Again, it's always we're taking a big leap to some goal that we've envisioned without really taking into account where we are now. So I think an important factor in moving forward is to recognize progress for what it is. You understand where you are and accept an improvement when you get one. I used to be an athlete many years ago, like many old people, and I was pretty good, but I always aspired to more than I was able to do, and it caused me a lot of disappointment. And then you look back and you think, well, you'd actually gone pretty far and you could see progress. And I think that can block us in all aspects of life, that we certainly want to have high goals, but you want to be reasonable about how we get to them and think in terms of what is the next step.
I completely agree. And when you're in the whirlwind of the storm, I think the passage of time hides progress often. You don't see the change for what it is. And, we're already half a decade past the pandemic, the clock is relentless here. And actually, when you look back, even in the environment, we were just talking about sensors, but even looking at where we are with what we've coined the term low cost sensors now compared to where we were 10 years ago, it's changed out of all recognition. So things do move and we do improve. It just feels pretty slow from the inside sometimes. One of the other things you mentioned there was the lack of policing and accountability, like this notion of the minimum becoming the maximum. I think that's probably a truism no matter where we're looking in the world at ventilation. That's been a perennial problem, hasn't it? And even if our standards aren't perfect, which, they never will be, we'd certainly be in a better place as a society if we were even just meeting the ones that we've had or have. I, I'm not sure how we fix that. I don't know what needles or dials need to move for that to be taken seriously. And here again, and you frame this very well, we're not talking about this top tier of buildings that are progressing towards well standards and so on. They're very necessary, and they're a lighthouse for how buildings can be, but they are not representative of the built environment. And for the rest of the built environment, this run to failure place, these environments that never met the standards on the day that they opened, never mind 10 or 15 or 20 years later, that's a challenge. And it's across residential and non-residential spaces. What do you think has to happen at whether it's a local level or at a national level to really get a handle of that? How do we start getting people to take the standards and the advice that's given seriously? Do people ultimately need to start being thrown in jail for this stuff, or what do you reckon moves the needle here?
At least in the U.S., what I've seen in the energy arena is a possible approach that first you simply start measuring and reporting some key performance indicators. So it's got to be something that you can do at scale, affordably. Everyone can do it, and then you've characterized the baseline of buildings, and then you can start putting forward, I think, levels of performance that are attainable, desirable, and either incentivize them or eventually penalize them. I think that's where disclosure laws have gone. So in New York City, we've got buildings now with report cards on them for energy that have a letter grade on them that anyone would recognize from school. And I've noticed that some of the places that have low grades, they conveniently put them behind a big potted plant outside the front door because they don't want people to get the idea that they've got low quality assets there. But I think that's a start. Again, it comes back to economics, doesn't it? We can imagine enforcement that would be very burdensome on the owner and would require them to invest a lot in reporting. We have to think about something that's actually feasible. Our ventilation rates, what they're supposed to be. Do we have reasonable PM levels indoors? So simple tests that could be done with pretty inexpensive instrumentation periodically. I just don't think it's realistic to imagine that we're going to put in place permanent instrumentation in a large fraction of the building stock in the near term to be able to do that. That is where we want to head, and we can do that with new buildings where there's the budget to support it. But I think in the interim, we need to have some way of characterizing, at least in a coarse way, what indoor air quality is, and then educate owners so that voluntarily they'll do things that aren't going to be very expensive for them to implement, and you can move on from there. So I just see this as a very incremental process, and I think it'll be successful if it moves at a sufficiently rapid pace that we're actually making progress, but not so fast that there's pushback on it. Now, we've seen in the U.S. in the last 6 months that some things that we thought were really sacred and accepted and settled can be reversed. Environmental regulations of all types, efficiency requirements for cars, renewable energy projects. All these things that we think, oh well, we're moving in this direction. It can be one step forward, two steps back sometimes.
Yeah, no, very true. I mean, one of the interesting things that happened in Ireland during the pandemic was a lot of opposition government requests that we had rules about, in the first instance, workplaces. So there was a lot of pushback about how we actually hold employers to account. And one of the outcomes of that was a code of practice for air quality in the workplace, which was actually a really simple document. And I mean, I quite liked it because it just set, apart from all the usual health and safety blurb that goes with it, that's fairly impenetrable language. At its core, it effectively asked two things. One, can you demonstrate at least every 2 years that the building is performing as intended from a ventilation perspective? So is there documentation that somebody's actually checked that that meeting room 2 is delivering the prerequisite amount of air changes for that space? And if you can't do that, are you monitoring it in some way that enables you to determine the same thing just at a really basic level? It's interesting because it's kind of quietly working away in the background. And what's happening is that as premises are getting their typical health and safety inspections, as they often do by the health and safety inspectorate, it's the guy that comes around and checks that your forklift has got the right license and that the shelving is still fit for purpose. That guy, he's asking now, can I see your ventilation risk assessment, please? And the answer invariably is, my what now? And these guys aren't there to trip people up. They go, well, as a premises, as an office, you need a ventilation risk assessment. There's guidance on the site. I'll be back in 2 weeks' time to check that you've followed up on these things, and this will be one of them. And they then, for the first time, have to do a ventilation risk assessment and realize nobody's ever checked the ventilation systems before, and now have to do something about it. It's got a bit quiet, unfortunately, but I think it's one of these things you won't hear about. I just think premises after premises is just getting that conversation, and hopefully slowly it moves the dial. But I was talking about this in the week, that I think some of this is on us. I think with that awareness, we need to empower people to put them into the position to ask the questions. When was the last time this office was checked, ventilation system was checked? And I don't mean the aircon being serviced. I mean, the same people that are turning up and checking that the refrigerant's still there. We should be expecting equally people to be popping around once every year or so, making sure and measuring flow rates into spaces, and at least checking that buildings are doing what they should do. It's not a big ask, really, but it doesn't happen. That's the problem.
Yeah, and I think another possible barrier here is the credibility of the whole inspection process. So, I think if the building owner or operator believes that the inspections that are being done, the requirements that they have to meet, are actually going to create a tangible benefit, that's important. There's a certain kind of inspection, I think, that is cosmetic or seems like a scam, and I've run into that pushback when I've suggested that we really need operational requirements and inspection for buildings, and then a lot of people will pipe up and say, "Oh, well, that's just paying money for nothing," like tailpipe inspections on cars and that sort of thing. So, again, it's getting the people who really are trying to lead and make things better to understand the mindset, the point of view of those that these requirements will be imposed on, and really think through, what do I really need to ask that question? Do I really need to get that data? What's really essential? And then I think over time you can develop some confidence that that's a good thing. I don't think anyone complains about having the fire inspector come and check the building out to make sure that things are okay, or to know that the health inspector came to the restaurant you're eating at and reviewed the condition of the kitchen. So we need to, I think, understand that indoor air quality, considering that we're exposed to indoor air almost all the time, is something that's just as important to be confident of that it's of acceptable quality.
Yeah, interestingly, I asked Valerie Leprince of Cerema about inspection of post occupancy buildings, about inspection regimes, and they did a bit of work in France looking at this and largely concluded that it was impossible to inspect existing buildings. They'd just never been set up to be inspected, which made the job in a lot of cases virtually impossible or cost impractical to do. And ultimately in those spaces, you just had to monitor them. There wasn't really a practical way to physically measure air movement easily, which is disappointing. I mean, one of the things that perhaps will move the needle a little bit is that this breaking down of silos that seems to be happening more and more. That the combining of engineering with building physics and science, with health and the health community. I was talking to a guy called Sir Stephen Holgate there a couple of weeks ago. He's a very renowned physician in the UK, been involved in many of the air quality standards that have ultimately been put into place. In fact, he was the guy that was the star witness that was the first case in the UK to actually directly attribute air pollution to a young child's death. So quite well known for that. And we were remarking in our conversation that actually the medical community needs to step up here a little bit. That largely from the outcome perspective, from an internal air quality and even an ambient external air quality perspective, the medical community has largely been missing from this conversation. And that needs to change. And often they can be real movers of the needle when it comes to shifting things. We've seen that with smoking and other health impacts that they can actually have an impact.
Yeah, I think we saw in in the pandemic that the great gulf between the physical sciences, engineering community, and the public health and medical communities. And I do think we need to bring them together because currently, the approach has been to simply treat the consequences of the environment rather than to treat the environment so that the consequences don't occur. That was, I think it was back in 2016, if that's the right year, when we had an ASHRAE IEQ conference in DC that was focused on policy. We had a gentleman who was from, I think, the National Council for Healthy Homes, and he was talking about asthma and about the asthma attacks. You take children to the hospital and they go to the emergency room and you treat them and send them back to the same environment. Why aren't we fixing the environment and look at the cost, the societal cost of the, that healthcare burden? It's really, we can view buildings as being an important piece in resolving our healthcare cost issues if we just focus on prevention by having better environments. I agree with that sentiment that's coming out of the Department of Health and Human Services these days, if not the actual ways in which it's being implemented.
The medical community really needs to be asking the question, tell me why your environment isn't a good story for the symptoms that I'm seeing, and for the engineering and scientific community to understand the language and the motivations and framing of the medical side of these conversations for us to better frame it in a way that they can use and use as a tool. Because it's fascinating when you see the medical community find themselves in our community. They're fascinating conversations to have, as those you can see those dots being joined, can't you, in real time in those conversations.
There's still in retrospectives on the pandemic a surprising tendency to just never get around to talking about buildings and airborne transmission. I listened to one of my favorite podcasts last week, and they had a whole episode on the pandemic, and it turned out to be all about vaccination. Um, they totally skipped over the airborne transmission issue and the things that we could have or should have done to reduce risk in that way. And I think that's in danger of being forgotten again. But there's something that the medical community and the building industry, building science, need to get together on is, can we tell what things we can do in the indoor environment that are actually going to be helpful? Because in the end, it's going to come down to can I see the benefit of the investment I'm making in hopefully improving things? If you can't show that connection, if you can't show the cost benefit, then I don't think we're going to make much progress.
So we're entering an interesting period for ASHRAE. It's a new presidency for the next couple of years, and I can't remember the precise name of the theme. You might be able to correct me on it, but it's certainly human-centric and health-focused to some degree. Is that correct?
Yeah, I'm forgetting myself.
Yeah,
Bill McQuaid will
yeah.
not be happy with me, but I'm forgetting exactly what the theme is. But it's essentially healthy buildings, including water, and the importance of indoor environmental quality.
Yeah, let's come on to water actually. And sorry, Bill, for our tardiness in not actually writing down what the title of the next period is, but we do know it. It's certainly to do with health, more of a focus on health, buildings and health, and human-centered approaches. As someone that's been a past president and has been in the seat of ASHRAE in these positions, do you see these kind of 2-year periods of presidency as distinct phases, and if they are, and these themes can resonate down through the organization and into industry, what's your kind of hope for where we are now, and what this next phase of the ASHRAE movement's going to be?
Well, just to make sure we're correct here, the presidency of ASHRAE is 1 year. Many organizations are longer, 2 or 3 years. So it's kind of difficult when you've got 1 year to get a theme put together, and then you put it out there and hope things will happen. But of course, you're working your way towards that for several years. I think that when we consider things like presidential themes in ASHRAE or the initiatives of other organizations, the most important thing is follow through. I think that you aren't really going to see the fruits of a good idea or a well-formed program that you've started within a year, but yet that's what everybody wants to see, right? The person who is the president wants to see some tangible positive outcome before their term is over. I was president in 2013-14, and I didn't take a real narrow indoor air quality theme. I was focused on planning, actually, the importance of having goals, but also of planning how to achieve them in reasonable ways. And one of the things that I emphasized was getting back into a leadership position in indoor air quality, which I was arguing ASHRAE had somewhat lost. And so now I look back 10 years later, and I can see a lot of things that have moved forward. I went from being president to being the chair of the strategic plan committee and got indoor environmental quality into the plan. It's like we were saying before, these small steps forward that accumulate. Bill McQuaid, the current president, was the vice chair of the planning committee when we wrote that strategic plan that rolled out in 2014. So I kind of see where he is now as a step that it's taken 10 years to get to, when we had already put that idea strategically into the organization. So what's more important to me is the organizational commitment, and are they structuring the organization to do the work um, in the background that needs to be done. It's not so much about getting out and making public statements and uh, convening meetings to discuss goals. The question is, are you actually working on them today? What are you doing today in your office by yourself, or in your committee within the society to get things done? And I feel very positive about that. I think that the awareness of the importance of IAQ and indoor environmental quality more generally is higher than it's been within ASHRAE since I got involved with it. So that's, I don't know if that's a cogent enough description of how I view it, but I think the presidencies, you can be a bungee boss, right? Come in and we have ideas, and they either take or they don't, and you're gone and someone else is there. It's workforce development, it's indoor environmental quality, it's commissioning. We're going to get this kaleidoscope of themes that come along, and they're all good. But as a president, I think what you want to have come out of it is some momentum that will survive your year in office, and that those things will actually take root and grow.
So back in 2013, 2014, when you took on the presidency, what was kind of driving your perspective? What was the landscape like at the time in ASHRAE, where you were looking around and saying, look, I think we need to put ourselves back more in the driving seat from an indoor air quality perspective, as an authority voice on the subject? Were there things in play that were kind of driving that perspective?
Well, I had my own long-standing view of things that I had an opportunity to express. I think that one thing that I was concerned about was just the extent to which ASHRAE had gotten focused on energy and now carbon, pretty much to the exclusion of anything else. I mean, if you're going to pick something else that ASHRAE was very involved in, it was refrigerants and environment. So, I felt that IEQ was kind of a backwater in ASHRAE, and we needed to bring it more to the front. That was about the low point, I think, of ASHRAE being um, the organization everybody would point at when they wanted to talk about how poor our indoor air quality standards were. My friend from Cambridge, Massachusetts, who likes to talk about ASHRAE standards and a few others. Um, so I tried to get us moving in that direction. I think the other thing that at the time was a real issue for me was, how global is ASHRAE going to be? Are they really going to make the most of the opportunity they have to be a global society? At that time, we didn't have a European region. We didn't even have a chapter in the UK. We had the region at large that covered Europe and the Middle East and Asia. And so I spent a lot of time traveling and trying to find common cause with other organizations, and to encourage our members to be more active in their regions and to partner with the regional associations. So we did things like visit South Africa for the first time in 13 or 14 years. There hadn't been an ASHRAE president there, and it took a while, but they have a chapter now. And I visited my friends at Loughborough and persuaded them to start an ASHRAE section, and there's a chapter in the UK now. And I think we've also seen finally, I think, acceptance that yes, it's okay to have ASHRAE chapters in countries that have their own national associations, and that we can work together quite effectively and collaboratively. I think if you look at India, that's a good example. The relationship between ISHRAE and ASHRAE is very strong, and it could point to a lot of other places too, but that's probably the the best example. I was just at the Region 15 regional conference in Kathmandu, and was talking to the regional director there. There are currently 10 ASHRAE chapters in that region, and he thinks there's potential to triple that before his term is over. This is someone who became the president of ASHRAE when there were 10 ASHRAE chapters, and there were 100 by the time he was done. So, I think we could see some interesting global growth, and I think the existence of a global society that ties all of these folks together really could be a very effective way of addressing these regional issues. We have both the global research community tied in, but we also have people on the ground around the world who understand their local issues and can deal with local politics and climate and economic and cultural adaptation issues.
Yeah, I think that's one of the real strengths of ASHRAE, is that its ability to straddle the coalface with the academic, because that really helps advance practicable solutions and standards, because you've got people going, that's not going to work here, sunshine. We need a workaround for that here, and it gets developed and looked at it. And at a basic level, what's the basic pitch for a chapter? What value is there to a region having a chapter of ASHRAE in it? At the end of the day, why are people starting up chapters? Because ASHRAE has been phenomenally successful at that.
Well, I think it just shows that the strength of the organization is the grassroots structure. You could, if you didn't have chapters, or very few chapters, like many organizations, you would pay your dues and you would get a magazine, and you might go to a conference now and then, but it's only a small fraction that actually go to conferences. So if you have a chapter, you have an active technical program locally that addresses your issues. You have half a dozen speakers a year, and you can bring in distinguished lecturers. People like me will fly halfway around the world to give a talk, and so you start to spread knowledge very effectively. And then you have technical expertise that's there, that can be offered to local authorities and to the community, and that starts to build in very, very beneficial ways as well. Yeah, so I think it's the grassroots are absolutely essential. On the other hand, it also creates an interesting duality in the society, that you've got some people whose involvement is almost exclusively at the level of society activities, that they do research, they're on standing committees, and they may not even attend a chapter meeting, but the vast majority, their main interaction with ASHRAE is through what their chapter does, and these regional conferences kind of tie them together. So the conference I was just at had the delegates from all of the chapters that were there to report on what they'd been doing, so they get to see what each of them has been up to, and they make motions to the society about things that they might like to see changed, and they have their nominating process there too, to put forward candidates for the various offices. So I think that's really key to its effectiveness. And you see lots of organizations trying to establish chapters, but it will take them a very long time to have as dense a network as ASHRAE has around the world. I was surprised to find that hadn't looked for a while. 31% of the membership of ASHRAE is now outside of the U.S. and growing rapidly.
I'd like to borrow your attention for just a moment to discuss ACO, a partner of this podcast. ACO, an EI company, specialises in pioneering new technologies in fire, carbon monoxide alarms, and Internet of Things technology. Many know them as the go-to company for these products. In fact, this year they're celebrating 35 years in business. I particularly know them for their outstanding work in the housing sector with their HomeLink offerings, aiming to solve some of the industry's most serious challenges. The technology incorporates environmental sensors and a gateway to offer connected home solutions, which has a proven track record in helping landlords reduce operational costs and carbon emissions while improving residents' well-being and safety. Issues at the heart of the housing sector, like damp and mould, fuel poverty, and energy efficiency, are all in the crosshairs of ACO. I've been amazed at how they are innovating here, with a laser focus on unpacking some of the complex nature of these challenges in a way that answers the what next question we so desperately need at the moment. They have a great network of experts and installers. If you're in housing, they are definitely worth talking to. Trusted is an overused word, but not here. Ask around, and ACO are synonymous with it. Details are in the show notes and at airqualitymatters.net and at ACO. That's aico.co.uk. Now, back to the podcast. How does knowledge transfer make its way up the chain in an organisation like ASHRAE? I can imagine the trickle down working very well, and I can imagine the alteration to that knowledge base being refined and localized by chapters. Is there a feedback upstream as well within ASHRAE that the people that are, like, for example, we'll come on to it in a bit, like 241, are able to understand the perspective of regions when developing some of the core principles and standards of the organization?
Yeah, I think that happens, and that's another thing that kind of comes out of this regional level of organization. So there have been motions made, for example, from regions that cover Canada, that ASHRAE needs to do something about air quality in buildings that have spaces that are used for ceremonial purposes, where things are burnt, smudging ceremonies and that sort of thing, right? Because right now ASHRAE standards simply say smoking spaces must be isolated from the rest of the building and aren't covered by the standard. So we're trying to deal with that. We've had motions come forward about other regional issues that have to do with the culture, how people dress, and your thermal comfort data aren't sufficient to cover the kinds of clothes that we wear, all sorts of things like that. Occasionally regions will scrape together funds to address some of their regional issues, but I think it's most effective when those ideas get into either the standards process or into the research funding allocation process. Then somebody's got to write work statements for the research projects. But we do get that kind of feedback from the grassroots that goes, I guess, up the chain, although ASHRAE would say it's down, because they say the top of the organization is the members, right? They show the pyramid that way.
That's an interesting concept, actually, flipping that the top of the pyramid is the broad part, actually.
Yeah. The other thing, the area where I think there's been a lot of response to requests over the years has been weather data. ASHRAE has been one of the main sources of weather data, both for design and for energy calculations. And its little TC 4.2, the weather information, has done a great job of putting together standardized weather data for hundreds of locations around the world, just upon request.
The better that is, the more power that has, I think, because there's a lot of differences regionally, but there's also still a lot to learn from different pockets. People are fighting different but the same battles at the same time often, and if one area is doing something well and having success, if that could be communicated and there are lessons to be learned, that's a really powerful tool.
Sure, and there's depending on your ability to participate, I think we get a lot of input from global sources now. There are parts of the world where heat pump technology has been leading North America for a long time, and others where, out of necessity, renewable energy has been leading, like solar desiccant air conditioning systems. There's not a huge demand for those in the U.S., but in other parts of the world, that's a really important technology. And so by having this cross pollination between uh, national, regional societies and a global society, I think we get a benefit from hearing about all of those things, and having that inform the perspective that an organization like ASHRAE has when it writes standards and guidance.
Yeah. And I don't know how much it is within ASHRAE's wheelhouse, but what I'm really interested to see over the next decade or so is the learnings that can come from areas that have managed to instigate in some way habits and culture change in their areas, and particularly regions where that's where the low hanging fruit is. We were both in India there a few weeks ago, and there's so much potential to improve outcomes just by awareness, culture, and habit change in the right places. You know, like you say, sage burning, burning of things, how you manage cooking, fuels, managing more basic spaces, those kind of things. Lessons from there can be applied in all sorts of places, for everybody. And one of the things we've got to get better at is figuring out how to get people to be thinking about ventilation and air quality and having the agency to do stuff themselves. I always talk about Germany and Luften, the culture of airing the home, yet in Austria, very close by, there's a culture of coziness, which is basically shutting the building down, and being in a warm, stuffy environment effectively is seen as a positive notion rather than a negative one.
I lived in Denmark for 6 months. I don't remember Hygge involving closing the windows, but they were into that idea too, of in the cold
Yeah.
months, being cozy, comfortable.
Yeah. No, it's I think there's so much that can be done in that area that we need to, and again, it's another opportunity for breaking silos down, bringing the citizen science and social science aspect of the built environment into the fold as well, learning how we communicate some of this stuff. Because one of the reasons, we're all the way back to the beginning of our conversation. One of the reasons we see this big gap in performance is people don't ask the tough questions regularly enough. They're not thinking about the spaces that we're in. I always say to people when we're talking, we've been talking for, nearly an hour. Not once have we gone and thought about the quality of the air that we're breathing. We're literally hardwired not to think about this stuff. And
Yeah, well, of course,
there's,
got my
yeah,
monitor
yeah.
here,
You and me
and
both.
I've got a HEPA filter running over here in the corner.
Listeners always comment that they can see the light slowly turning from green to yellow to red behind me, telling me that the air quality is deteriorating. So, it's a funny one. That awareness, is a big battle, and a lot of that. But even if it's not an awareness, even just at a habit level and at a culture level, just if you can move the dial a little bit, you could have a big impact.
Yeah, I live in an area with good outdoor air quality most of the time, unless we're having a wildfire smoke event. But it wasn't until I lived in Denmark and got used to airing the building out a couple times a day that I realized, hey, most days, spring through fall, I can open windows in the morning, and maybe I won't have to run the HVAC, and I'll have better air quality in the house. It just had never occurred to me. And this is one of those things that subtle tyranny of technology. I read in a reference I was using in a talk on smart buildings that I think I titled "Are We Smart Enough for Smart Buildings?" It was all technology is value laden. That somewhere in there, it may just look like a device that does something for you, but somebody's values are in there, and my example of that is the thermostat and the way we air condition houses in the U.S. Right? We have a system that controls temperature, and the way we think, when it gets warm in the summer, you close the windows and turn on the air conditioning, and that controls the temperature. And you may never open them again until fall. You just don't think to do it. But I spent 6 months in a country where I didn't have any cooling. I had radiators with dials on them that didn't even have temperature numbers, and I adjusted them until we were comfortable, and we had to open windows a lot, and it completely changed my thinking about how I interacted with my HVAC at home.
Yeah, no, I completely agree. So I was on a podcast yesterday, and somebody was asking me, what's the one thing you've done at home that's changed, materially air quality in your own home? And again, for me, I mean, we preface this by saying we're fortunate to live in a place where outdoor air quality is generally better than indoor air quality. Opening windows I've got decent mechanical ventilation, as people would hope and expect of me, but it makes a phenomenal difference to the air quality in the home. Is opening the home up to the environment once or twice a day can make an absolutely massive difference. And that's the kind of habit and culture thing that we've kind of lost. People had to control their buildings, many moons ago. And I certainly grew up with a mother that would come in my bedroom at far too early and throw the windows open, whether I liked it or not, in the morning. We've kind of lost that a little bit. And I think you're right. It's that kind of slow technology creep where the assumption is these spaces are going to look after us. And unfortunately, with ventilation, manifestly, we've failed. They don't get even close in most cases.
That's the sort of thing you could start teaching kids in elementary school. Just some basic ideas about air quality. It doesn't have to be quantitative, but just the idea that if you can let outdoor air in, that's going to make things better.
Yeah, just at a very basic level. I mean, in a complete switch from that at its very basic level to the having to fundamentally rethink how we think about ventilation in spaces. I was fascinated to talk to you about your experience of 241 or 241 or 241. I'm never quite sure what the colloquialism is for that standard. I think you say 241, don't you, in ASHRAE?
241, yeah.
Yeah. You led that charge, didn't you, Bill?
Yeah, and I still am the chair of the committee. I'm hanging on until we get it ANSI certified.
That was a fascinating standard for me because it was obviously born out of a crisis. There was a demand and a need. And, you were asked from the highest levels of government to sort something out in quick time as well. So there was an imperative behind that. Tell us a little bit about that story. And at some point, I'd like to dive into how you started coming up with and thinking about this notion of equivalent air change rates out of necessity, and where you think that takes us next. Because, talking of technology creep, like increasingly providers of technology are looking to facilitate and supplement buildings with various different ways of improving air quality. But at a very basic level, what was the story behind 241 and your involvement in it? Because it's the fastest a standard has ever gone through the mill in ASHRAE, certainly, isn't it?
Yeah, I'm sure it is. Yeah, 4 months of actual development time, 6 months from the time the board of directors agreed to do the project. It took a little while to get the committee put together and to start meeting. But it really, the backstory of that is the epidemic task force and the 2 years or so that we were working on developing guidance, really under intense pressure and without a lot of time to sit back and try to do things rigorously and thoroughly. So in April of 2020, when the task force started, the whole world was kind of in panic mode, and they wanted someone to tell them what to do. And so I got asked to chair that group, and I pulled together a lot of people who were actually later wound up being key members of the Standard 241 project committee, and we put together whatever we could find, and we ran into lots of knowledge gaps. One of the main ones was, well, no one has really figured out what is the right ventilation rate to limit uh, risk to a reasonable level for an airborne pathogen. Something that you can do that's going to be effective but feasible too. And then a lot of air cleaners are being uh, put into the market as the solution to COVID, and we hardly know anything about them. We don't have a lot of peer-reviewed research on them. We don't have consensus standards for testing them, just for uh, effectiveness. And then there's this whole issue of some of them producing byproducts. So it was really a difficult situation to be in. We did the best we could, and we eventually we started out by throwing everything against the wall, just like everybody else. Increase outdoor air as much as you can, put in more efficient filters, flush your building before and after use. All of these ideas that came up that that might be a good idea. And then after that first wave of guidance was out there, we started getting feedback on it about the energy impact, on the comfort impact. Is that really helpful? And so by the end of 2020, less than a year of operation, we had already started revising it, and we wound up with what you may have seen as our kind of our endpoint was this one-page core recommendations document that I think was really quite good, because it um, pulled back on outdoor air and said, no, you don't need to increase outdoor air at all, as long as you're meeting the standards and you use other means like air cleaners to reduce risk. Although we hadn't really defined uh, where you needed to get to, and we said that should be done with consideration for energy and economic factors. And we figured out uh, that flushing between occupancy periods probably wasn't all that helpful, so we dropped that. So in the end, we'd gotten to, I think, a pretty reasonable group of recommendations. But the two things that were really missing there were actual ventilation recommendations, quantitative ones, for which we were just being beaten up mercilessly by all sorts of people. We didn't think that there was really a good basis for it. You look at what was being recommended in those days. We wound up eventually with CDC's 5 air changes per hour of clean air. Back then in 2020, 2021, the talk was about 5 air changes or 6 air changes. Where did that come from? Somebody looked at ASHRAE Standard 170, the healthcare standard, and said, well, patient room has 6 air changes per hour of clean air, so that's what we'll use. And then that got applied to classrooms and everywhere else. So it was just a mess. We didn't believe that those numbers were really defensible, so we just took our lumps. And then we sunset the task force as it was in the spring of 2022. That's one of the things I was committed to when we formed the task force. Is we're not going to be the epidemic task force forever. We're going to produce our guidance. We're going to make some recommendations, and then we're going to shut down and go back to what we were doing. So we did that. Personally, like in the background as that was going on, I was going to a lot of meetings and arguing for the need for regulations and standards. And after the White House changed hands and the Biden administration got in, suddenly there was an interest in in buildings. And then at the end of 2022, the request came from Ashish Jha that ASHRAE develop a national pathogen control standard. The partially the purpose of that was to be able to say that there was a standard that would tell you how to protect your building when the COVID restrictions ended in March of 2023. So that's how the committee got going. We had the opportunity to do take a mulligan on what we had done in the epidemic task force. I had a lot of people who came right out of there. Steve Martin from NIOSH, air cleaners. Max Sherman had been the residential guy, and he became the vice chair. Pavel Wargashki, all sorts of names that So we kind of got together and said, okay, we got a chance to do this over. How are we going to do it? And then the most important thing was to come up with recommendations based on risk assessment for the clean air delivery rates. We'd already raised, without really naming it, equivalent clean air in the epidemic task force. I think we call it equivalent outdoor air. There's actually an equivalent outdoor air calculator that you could use that the epidemic task force produced that would let you combine filters and air cleaners together. We also had the building readiness plan. That was an epidemic task force development that went right into 241. So we took these ideas that looked like they were going to be useful, and instead of mimicking our other ventilation standards, we're going to start with this single metric equivalent clean air that we think is much better overall than saying, well, we've got so much outdoor air and we have filters of efficiency X, Y, Z, and we don't really know what they do when you put them all together. So the most significant piece of work was doing that risk assessment, and that was led by Ben Jones and Chris Idden from Nottingham and I guess UCL. And that was really a unique approach. It was different than what anybody else had put out. And so now we've got these ECAI values that apply to infection control. And on the air cleaner side, we put a lot of effort into developing testing procedures or improving existing procedures so that they would allow air cleaners to play. Big mistake made during the epidemic task force days, and by not just ASHRAE, but everyone else, was the tendency to talk about different air cleaner types instead of talking about what air cleaners needed to do. So if you go from sort of comparing technologies to, well, they have to be safe, and then we apply them based on their measured effectiveness, that allows you to create a level playing field. It stops the lawsuits about, you're saying this technology is good and that one isn't. So I thought that was another major advance that we made, and that standards development is still ongoing. There's some other ASHRAE standards for testing that have been developing. The ASTM has got a standard for byproduct production that it's working on that I think we'll reference eventually. So I'm very pleased with the outcome in terms of having developed an approach to infectious aerosols that I think was unique and better than what we had done in other areas of air quality. The closest thing to it would be perhaps the indoor air quality procedure, except it doesn't have a risk assessment behind it. This is just a list of 15 or 16 things that we know are indoors that are harmful, but what do we get when we combine all of those? So we were moving in the direction of a real risk assessment based approach to air quality, which you also see in the recent work by Morantes et al. It's maybe not the last word, but it's a very good advance, and that comes out of Nottingham also. And we have now, I think, established this concept of equivalent clean air, and it can be applied to other contaminant types. I think that's my hope, is that eventually all of our standards to some extent will look like 241, because instead of simply specifying outdoor airflows, there may be a minimum outdoor airflow because we've got to cover our rear ends. But that if we understand what the contaminants are that we're trying to control, and we understand the performance of the technologies that we use to control them, then we ought to be able to have more energy efficient, more affordable indoor air quality across the board, but then we'll need to have equivalent clean air requirements for particles and for gases and for pathogens altogether. And the other thing that we did in the standard, obviously, I think, was introduce the idea of resilience in indoor air quality. Uh, it dawned on me somewhere along the way during the pandemic that all of our standards that we've spent so much effort developing are for normal operation. And there wasn't really a thing in 62.1 or 62.2 or even 170 about what happens when there's some kind of an unusual event, an emergency. And so in the future, I don't know that we'd even need a 241 if we had an acceptable indoor air quality standard that had equivalent clean airflow requirements for all major classes of contaminants and that dealt with resilient operating modes. I think that's my ultimate goal that I hope we get to eventually. I don't think it'll happen in my professional lifetime, but I think we're moving in that direction.
Yeah, and I think it's really interesting for me that there's a couple of ideas in 241. I think that beyond the obvious that are quite profound. One of them is this modal operation of buildings, that buildings can actually be in different states, or there's a requirement for a building or a space to operate at different states depending on a need. I think that's really important, and it really shifts. It's a nuanced perspective of how spaces should be managed. I think that's really interesting, and it kind of brings me to the kind of the accessibility conversation around spaces as well, but which I'll come on to in a minute.
Oh, the resilience is an interesting thing. Is that we were talking about the medical view of things before, and the definition of health, of course, is very central to that. And the World Health Organization definition has been justifiably critiqued as being not operational and unattainable because it strives for perfection that isn't possible. The most recent definitions of health focus on the ability to adapt, and so you could say that a building that's able to respond to whatever is happening, whether it's a wildfire or an epidemic, is in truth a healthy building in that sense.
Yeah, it's truly a building as a safe haven, to coin a BISA term. That you create a space. What's the point of a building? It's there for shelter and for health, and a platform for thriving and flourishing and so on. And that there are going to be different modes required of that space depending on what life frame you're in at the time, or what external conditions there are, particularly in a changing global climate as well. Of course, what we know to be true today outside may not be very similar in decades to come. So that adaptability, I think, is really interesting, and very core to one of my beliefs is in this necessity for capacity in engineering, that we don't deploy enough in ventilation. We see it in many other forms of engineering, this inherent redundancy and capacity of design to deal with a range of circumstances, a spectrum of potential risk. And ventilation has been a bit of a one-trick pony in that sense. We've tended to set arbitrary thresholds or flow rates, and they're immediately seen as the maximum achievable rate, and we're surprised when we see poor outcomes. And if we viewed it through the risk lens more, and there's no such, risk is not absolute, you can't define it, people's tolerance of risk will be different and so on, and we introduce that tolerance and capacity into our thinking with ventilation, our buildings would be in a far better position to have modal ranges of operation on various different circumstances. But at the moment, most buildings can barely achieve the minimum, even if they wanted to, never mind, have a spectrum of outcomes. I mentioned this to Valerie. We were having a conversation about TN68, and I said to her that we were talking about DCV, demand control ventilation, which is a similar concept in a lot of ways. This idea that ventilation should react to a range of conditions in a space. And I was saying to her, like, do you have confidence at this stage that that's the right pace and direction to be going in? That when we've looked at this much more kind of binary threshold approach to ventilation of X flow rate and so on, every time we look at it, we catastrophically fail to meet even those basic simple numbers. So what kind of a position are we in realistically to determine why we're seeing a failure when it's not just that, when we're starting to think about outcomes of risk, we're not just talking about whether a ventilation system is achieving 10 air changes or 7 air changes. You've also got what is the source at that particular point of time. What are the other conflicting factors that are having an impact on an outcome? So if you're measuring yourself on an outcome, it's a much more complex and nuanced place to be than just trying to say whether or not your room's doing 5 air changes or not. And we can't even do that very well. So it's a kind of, my question about 241 is the same kind of question, really, is that as great an idea as the equivalent air change idea is there not a risk of an unintended consequence that we just make determining whether we're doing what we should be even more complicated than it is already, on the basis that we can't even do the first thing right when we go and look at this stuff?
Yeah, well, of course, the prerequisite, the floor for 241 is the whatever your ventilation standard is in your jurisdiction. So we could say that you have to comply with 62.1, for example, if it's a non-residential building in an area where that's what the code's based on. So it's going to be no worse than the minimums we've established now, and it only goes up from there. I think there's some complexity to calculating what your actual clean air delivery rate is, but right now we're putting filters in however much recirculated air we have, and we're not calculating what the effect is. What does it mean to say I've got MERV 13 filters? Maybe I've got 5 CFM per person or 100 CFM per person, and that gives me 2 entirely different outcomes. I think the advantage is that we actually are quantifying the total effect. Now, there's so many things in the risk assessment for 241 that are very uncertain, and it may stay uncertain for a long time. But it's a lot better than not doing the calculation at all, and we've tried to be conservative. It's all based on steady state concentrations. So it's not really demand control. It's turn it on, turn it off when the extra protection when you think you need it, but someone could apply it and decide I want this all the time. And that's why infection risk management mode was intentionally left to others to make the decision on. So we would hope that public health officials would decide when they thought those protections were necessary. The CDC was hoping to give us some help on that to try to come up with some guidelines, but that's on hold at the moment. But that's a possibility. Or I say you can go to the other extreme. We only cover SARS-CoV-2 right now. I don't mean to say, because it's been misinterpreted, that it only applies to SARS-CoV-2, but influenza or some other virus would have a different level of infectivity, and maybe the requirements would be lower. So there are a lot of things we can look at going forward, but I think it's a pretty simple concept overall.
Yeah, and not to do it down, though, the positive side to that, and I think it's the same with demand control ventilation or more sophisticated ways of looking at harm in spaces like the work of Nottingham and these kind of harm intensities, is that, yes, in a lot of the built environment, we're a very, very long way from having sophisticated ventilation systems that can change modes and do what they should do and so on. but in just having the conversation, you're starting to ask the right questions, and I think that can often be as powerful as the engineering moves forward in itself, that you're actually thinking about spaces in the right way rather than just a kind of a blunt instrument of, this is what you're supposed to achieve, and if that is that the number I need to get away with getting to, or is that the number is a good out. We think too simply about ventilation in most cases. So when you start asking more nuanced questions about what is an air change rate, is it the equivalence, what is the thing I'm trying to treat, what is the harm impact of this, by that very nature, I think you start thinking in a better way about what spaces are for. And that ultimately can only be a good thing, because that just raises awareness. People start asking the awkward questions, and you have to start thinking about the answers for the first time.
Couple of follow-ups. Demand control ventilation. There's good demand controlled ventilation and bad demand controlled ventilation. The way it's usually applied is that you determine what the minimum outdoor air is that someone should receive in a given space, and then you make sure that nobody ever gets any more than that, right? So we only turn it down. It turned up means that we're at the full occupancy level, and we're only looking at outdoor air. We're not looking at PM or VOCs or other things that may have indoor sources, where if you reduce the outdoor air, those concentrations may actually go up, or humidity for that matter. So, good DCV should be looking at the key contaminants, not just how many people are here. Otherwise, you're creating a problem. And then again, if you look at it from the economic point of view, if you take into consideration what we know about health and productivity benefits, if you go to a DCV system that allows you to reduce the amount of outdoor air you're bringing in a lot of the time, then that ought to allow you to set your minimum outdoor air flows per person at a higher level. There's actually a doctoral dissertation by a guy named Johansson. I think he was from Lund in Sweden that showed that he has a nice graph in his thesis that I use in a lot of my talks that shows constant outdoor air flow rate versus demand control, the cost optimal outdoor airflow versus the salary in kroners per year, and it shows that the more valuable what's going on in the building is, the more outdoor air you can afford to provide if you've got DCV and you're limited to much lower levels. So, that's an important thing to be clear on. The other is that we don't believe in air change rates very much at all as a way of specifying ventilation. But an air change rate mostly gives you an indication of the clearance time for space. So every air change in a well-mixed space reduces the concentration, initial concentration, by 63%, right? So 5 air change rates should clear 99% of what was there initially in a kind of a pull-down kind of situation. It doesn't tell you what the steady state concentration is going to be. So that's why the ECA values in 241 are ECA per person, not air change rates. And we showed in some of the articles we've written and presentations that we've given that there's really almost no correspondence between a fixed air change rate and the ECAI in 241 when you compare them. Some of the 5 air changes per hour is a lot less than you need in some spaces, and it's a lot more in other spaces. And I think we can say that because we've done a uniform risk calculation for each space type to get the ECAIs. So maybe there's a role for air change rates, but I think maybe it's a minimum air change rate that we'd like a space to clear in some reasonable amount of time. But I don't think that's fundamentally the most important value. It's going to be the liters per second per person for infectious aerosols, and maybe something else for building generated contaminants.
Yeah, I was going to say that it depends on the source, doesn't it? Really, ultimately, what the target value is. It's been one of the interesting conversations to see actually at a European level under the energy performance of building directives. The latest revision is starting to set some standards around indoor environmental quality, and one of the unintended consequences, well, and I suppose it's an intended consequence, is actually is that a development of the development of categories of outcomes for indoor environmental quality. So setting category 1, 2, 3, 4, and 5 for some of the very basic metrics. We're not talking at a level that ASHRAE's been doing with the kind of the harm intensities yet, but even at things like CO2 in in residential settings or in office spaces, the VOC levels or even air change rates. But the interesting consequence of that has been a change in psyche at a regulatory level and a recognition that actually, so far, the way that standards have been written in most countries have been kind of normative values for general ventilation rates based on rules of thumb of what actually often going back to some of the original kind of likelihood of discomfort metrics in
Yeah,
the old days.
indoor areas. It's either okay or not okay, and
Yeah,
not
very
that there's a
binary.
continuum of quality. Yeah,
Yeah, so that kind of sets your ceiling or your line in the sand, and there you start to see the numbers that appear in standards and regulations of zero point 0.3 liters per second per square meter, or whatever it is that you end up with as a standard. And then, of course, all of the energy standards for those buildings are assuming that buildings are achieving have got that ventilation heat loss effectively when they're doing their calculations for their national energy standards. And one of the interesting things of this kind of EN process, this EPBD process, has been that, well, hang on a minute, if now there are categories of outcomes for ventilation and people could, the regulations are typically in most countries achieving category 2 or 3 or sometimes even 4 on this list. At a national level now, they're starting to go, well, what if somebody wants category 1 in their home? That's their choice. Like, they're perfectly entitled to say, actually, I want twice as much air moving through my building. That I think there's more value in this office space achieving a category 1 outcome from a CO2 perspective than a category 3. But that's put the regulators in a bit of a spin, because now all of a sudden they need mechanisms for figuring out at a national level what happens when people decide they actually want more air than they've assumed they're going to want. And that's really interesting. And it's similar in a little bit of a way to this equivalent air change rate, where you start asking these questions and saying, actually, what is ventilation all about? What's the purpose of it? And giving people some agency, perhaps even in achieving, what one building might want a 241 standard for infection risk because they've got a vulnerable population in that space. Another organization that has some risk of exposure to particulate matter might decide to do something different. Now, all of a sudden, you've got buildings that aren't targeting minimum standards. They're targeting outcomes. That creates a much more complex landscape from an energy
it does.
perspective,
I think we've got to flip the thinking to focusing on exposures and their consequences. The air change rate or whatever else we do is just a way of achieving it. And when we always think in terms of how of air changes, whether they're equivalent or not, that just keeps us locked into the idea that more ventilation is better. And as anyone who's penciled it out knows, every time you want to cut the exposure in half, you've got to double whatever the clean airflow rate is now. So quite quickly, the costs become infinite and the incremental impact becomes zero. You can't really go to more than maybe 3 times the base outdoor airflow before it just becomes a totally losing proposition. So that's why I think there's so much need to figure out how to make other technologies work and to continue to focus on reducing sources also.
Yeah, I agree completely. And the more assurance we have of those different approaches, I was speaking to somebody the other day about, far UVC, which shows some really good promise in the right spaces. And obviously we've got, filtration is, become increasingly more important. There's so many different ways now of treating our spaces. I think the MOFs technologies seem really interesting technology as well, particularly for things like formaldehyde and others. Like there's some really exciting developments and some really great potential, but it does make it far more complex. That's the challenge, and particularly difficult for lay people to navigate. We saw that during COVID with the air cleaning rush, that trying to decide, even for technical people like myself, I mean, I'm not as technical as you, but I'm technical enough, and trying to wade through the layers and layers of independent studies on various technologies, trying to figure out what was actually legit or not, was just impossible, like just literally impossible. So there's a ways to go, but if we can get those technologies into places where there's high trust and legitimate testing, and people can start to specify them as engineering solutions, it creates a really different landscape technically.
Yeah, it's a really interesting time. I think the emphasis on byproducts of air cleaner use during COVID, um, you can't unsee that, right? So in the past, we only saw air cleaners in terms of the good thing they did, and we weren't really counting the harm. But you have to consider outdoor air along with that. It's not that outdoor air is a pristine, perfect control, and everything else. We use it only if it doesn't produce any byproducts. But if that were really the case, we'd have to say you can't have any outdoor air in many places unless you're going to filter the ozone or remove it with a catalyst or something like that. So I think we need a new uh, approach to determining what's acceptable risk that takes the benefit and the harm together, and I think you have to establish um, somehow. I don't know. Can't say how to do it yet. Um, what levels of production of byproducts might be acceptable? If we're actually looking only at what's in the air and not what's coming out of different sources, then we could probably do that, right? Because um, we would want particulate matter to be in a certain range or below. We would want VOCs of certain types, formaldehyde, whatever, to be below certain limit. Is there a problem with using a device that creates a significant benefit that contributes to those sources, as long as we're also controlling them?
Yeah, I think that's a really profound point, and it's something that I ponder a lot. Is viewing this problem through the risk lens. And again, I think the I was exposed to the risk lens of the built environment because of the pandemic. I sat on a number of committees, as you did, obviously, during that period, and it was amazing to me at the time that the people that could move things forward in the absence of all of the knowledge were the risk people, because they were used to balancing up risk. This kind of idea that, am I doing everything that can be reasonably expected of me in the moment with the resources that I've got, approach to risk. It's a really fascinating lens to look through, and it's the challenge of that is how we communicate it. And you were making a really good point about some of these air cleaners. Yes, some of them might create ozone, or may not be creating ozone, but creating other byproducts because of the process that the oxidating process that they produce in cleaning. And And does that present a risk? Well, yes, of course it does, but does it outweigh the risk of infection control?
It doesn't even have to be risk. It's just an additional control requirement. You can set your goal wherever you want it, your threshold for some contaminant. And if you have something that's a source, then you need more control to get there. Some people don't like that idea at all. Maybe my analogy would be read the label on the next new drug you get, right? Well, this will, help you lose weight or improve your skin condition, but could cause a fatal infection in a certain part of your body, or cause liver damage or whatever else. We accept those sorts of things every day with things that we put into our bodies.
Yeah, but I think we're poor as a species, though, at an individual level of understanding risk and probability. That's the trouble, and you see that in the conversations that people have around things like vaccines, for example. That with the wrong narrative and dialogue, we can get very confused very quickly about what true risk is, or what probability really means to us, and that I think is a really big challenge. And as we start to have these conversations about saying, look, what's your goal for your, we keep talking about the indoor environment being the single biggest environmental risk that we face and has such a major impact on our health and well-being. But how do we actually lay that out for people where they can start determining those risks and probabilities of risks and making choice with agency in those spaces? And then, I think at a regulatory level and at a national level, we often have to make a lot of those decisions for people. Public health is a good example of that. But if we want people to have control of their own spaces and agency over their own spaces, we've got to figure out that the next phase of the 241s and the harm intensities and these 62.1s and 2s is to start communicating it in ways that people can make decisions about outcomes. Because at the moment, most of it's about minimum standards and thresholds. But if we want to move into that space of actually, I'm going to accept this risk here for this benefit over here, that's a very different space to be in. And I'm not sure how we do that either. That's a biggie.
There's a lot to explain. It's one thing to tell someone, well, you should have 20 CFM per person of equivalent clean air, and then to go all the way back to, well, and if you do this, if it's SARS-CoV-2 and you have this occupant density, and we assume a 1 hour exposure and a 3% or a 1% population incidence and a 0.1% risk of infection,
you've
this
lost
is the
people.
right number.
Yeah, but
right.
You've lost people at that point. That's the trouble.
Exactly.
It's how we frame that in ways. So again, talking to Sir Stephen Holgate about air pollution and health risk, he was very central to things like the ultra low emission zones in London. And that was a similar conversation in a lot of ways. Look, we're implementing these regulations and standards that are having a material impact on your businesses, on how you can drive in the city. We're moving pollution from one area potentially to another. There are upsides and downsides and exchanges of risk and costs and benefits and all of these things. It's a really complex thing to describe to people. The outcomes are materializing.
It's like with radon. I don't think anything works better for radon than to say it's the second leading cause of lung cancer after smoking.
Yeah.
Right. I think that's been quite effective at getting people to do radon mitigation.
Kind of, but the where I push back on you there, Bill, is that I talk about radon as literally the slam dunkiest of slam dunks when it comes to pollutants, because it's one of these pollutants that we know where it comes from. We've got a direct line from cause to harm. We know how to mitigate it. We know how to measure it. It's cheap. We know where it causes harm or where it doesn't. We've even got flipping maps that will tell you whether or not your building's likely to be in an area where you're going to see it. Yet every time we try and do anything about it, you virtually can't give a test away. People don't want to know. And even when they do know, often when you're providing major grants or even free remediation, people still don't want to know in a lot of cases. And it's a conundrum for me, radon. I don't understand why at this stage radon isn't just buried and put to bed yet, because it literally, it couldn't be a more squared off pollutant in the built environment, radon. It is its own thing. It's unique in that way. Yet at a public level and at a risk level, I mean, in my country, we've got major renovation strategies to renovate half of the existing building stock, 1 million homes in a country of 2 million properties. And we don't have a strategy for radon. We are undoubtedly fundamentally changing people's homes for better or worse, that already have high levels of radon. And we have no idea what we're going to do about it. And it's just that it puzzles me, radon. And Canada has similar problems, I know. It's a strange one, radon.
Well, there's also the landlord tenant issue. It's our daughter and her husband had a house not far from where we live, and it had high radon level in it, and the landlord didn't really see the need to mitigate it because people were coming and going. So the tenants aren't going to be living there very long anyway. So why should I do this?
Yeah, it's interesting, isn't it?
They open a window in the basement.
Yeah, I mean, a good example of that is that you can sell a home, and you're not, in many countries, you're not legally obliged to tell the people that are buying your home if you know that it has high levels of radon. So I can be in a home that can have dangerously high levels of radon, and I have no legal duty to tell the people that are buying that home what they're buying. But that's down to a kind of a consumer protection level thing. It really is that fundamental. Yet I don't know what it is, whether it's because it's tied to perceived property value or something, that it just makes it more political than it needs to be. But it shouldn't be. So I would like to see some focus there, because I think if we can't fix and solve the radon problem, we're going to struggle with anything else, because everything else is significantly harder to identify, measure, and remediate often. Like radon is about as easy as it gets.
Yeah, well, and if there's any indoor air pollutant for which the case for remediation is unequivocal, that's it. You're quite right. Yeah, why isn't it just a regulation?
In many countries, and they've only been fairly recent for radon barriers, in foundations and things like that. But it was only up until recently that I discovered that, it's the home, that the office that I'm sat in right now has a radon barrier under it when we built it nearly 20 years ago. It is only part of the protection. It's a barrier doesn't protect you. It's the combination of a barrier and negative pressure and a sump. It'll only
the subslab depressurization.
It will only work. It only mitigate about 50% of it if it's just the barrier alone. And they're notoriously difficult to keep unbroken barriers during construction. So it's very rare that a barrier remains intact anyway during the construction phase. I think it's that radon for me is a good manifestation of some of the fundamental challenges we've got in fixing some of these problems. That if we can't see radon for the problem that it is, when we get to things that are more nuanced, like particulate matter, where you've got a range of sources and ranges of harm, and depending on what it is constituted of, and it's multi-systemic, so it can impact every organ in the body. So drawing straight lines to what caused what from a health perspective is fairly difficult. Radon's easy in that, through that lens.
At that level, yes. But in some of these other things that we say we want to make the basis of standards, school performance and productivity and other aspects of well-being, they're confounded by so many other factors that it's really difficult to get a high degree of certainty about them, and we may never be able to do it at a really granular level. But I think at the population level, those studies are uh, are persuasive.
Yeah, really interesting. I mean, one of the things that has been interesting for me, one of the new perspectives I've seen is this view of the built environment from an accessibility rights perspective. And I definitely think there's an angle here we haven't leveraged as well as we could do. And 241 could be another good lever there. And that's this idea that there are sections of society, and a lot of them, a surprising amount actually, that spaces present a risk to them and actually an accessibility issue. You know, if you're a child with, you know, parents with autoimmune diseases or treatments for cancer, or, you know, you've got certain illnesses yourself, a school classroom presents an accessibility issue to you or family members because of the potential risk of infection, and likewise many other public spaces. And I think the interesting idea here, and, you know, I've spoken to the Safer Air Project and others like this quite a bit, is this, it leans into the fairness angle, which I don't think we've lent into from an air quality and ventilation point of view before. And that's this idea that I think we as a species, we can be quite good if we see unfairness in society. It's why we've created accessibility rights to spaces like banks and classrooms and schools for people in wheelchairs, people with hearing and seeing difficulties and so on. This idea that someone's going to miss out on something because of an inherent disability or whatever it is, risk. And air quality is the exact same, ironically, and often with a lot of these accessibility solutions, there are co-benefits to them. So, you know, providing better wheelchair access and things for people in wheelchairs also helps mothers with pushchairs and people elderly moving around with Zimmer frames and so on and so forth. And similarly with accessibility, if a child has an issue and you have a mode of operation like 241, say, okay, this is now an accessibility space and this is the rate we're going to achieve for it. Great. You also get the co-benefits of cleaner air and better cognitive performance and less absenteeism for everybody else at the same time as well.
Yeah, it certainly doesn't harm anyone else. It's a benefit to all of them. But we're not there yet, of course. And I think it's a direction that we ought to go, and it is, you know, analogous to making buildings resilient with respect to other things. But I think that's a very important issue.
Yeah, I'd like to see that. I'd like to see spaces where accessibility is identified, that effectively they can turn on a 241 mode of operation some way, and say, right now this space is now it's the equivalent of putting ramps in. The other interesting thing is often there's a good lead time for that. It's a different approach. You're not saying all buildings now have to meet. You know, often you saw that with accessibility, that they gave people time to say, look, if you operate a public space by 2030, you will need to provide ramps or ways of people accessing that space. You could do the same in the built environment from a ventilation perspective. Say, look, we're going to treat these spaces for equal rights for accessibility. And by this period of time, you will need to have in place the ability to turn that on if necessary, or even have safer spaces, so zones within those buildings that present less risk than others. You know, you might not need to do it in all classrooms or all foyers, but you might provide safer spaces for people. I think it's an interesting idea.
Well, it's ironic that we're more likely to put an area in a building so that people who want to smoke indoors can do it, but we're not taking care of the other issue of just people who are harmed by the normal level of air quality.
Yeah, no, absolutely. Bill, it's been brilliant chatting to you this evening. I knew it was just going to be one of these wandering conversations. Like very rarely do I start a conversation off with few show notes and questions to go through. But in our recent conversations, I knew you and I would just start chatting, and nearly 2 hours later, we'd still be going.
Well, it's been a pleasure, and if we had the Jim Beam here, we could probably keep going for a while longer.
Indeed, yeah, but probably less coherent as the time went by.
Indeed, progressively.
Yeah, or animated. Bill, listen, it's been brilliant. Pleasure talking to you as always. Thanks so much for giving me your time.
Yeah, likewise. A pleasure. Bye-bye.
Thanks for listening. Before you go, can I ask a favour? Before you shoot off to whatever it is you have to do next, or even the next podcast, if you enjoyed what we've been talking about here, please do spread the word and let's keep building this community. And don't forget to check out our sponsors in the show notes. Ultra Protect, Eurovent, Erico, ACO, Farmwood and Zender, all amazing companies, and without them, this podcast would just simply not be possible. Check them out in the show notes at airqualitymatters.net, and do check out our YouTube channel. All this content is there, plus much more. See you again next week.